Jai Hind. The topic which we are going to discuss today is relational algebra. We have already seen what is relational calculus. Relational algebra, basically it is a procedural query language, and it consists of a set of operations that take one or two or more relations as input and produce a new relation as their result. So these are the basic operators which we are having the relation algebra, which we are going to see one by one. Very first one is my select, symbol is sigma, then project, symbol is pi. This is union, set difference, Cartesian product, and for the renaming a relation, we are having a row operator. Let's begin with the select operation. The select operation, that is select tuples that satisfy a given predicate. We use lower, that is the Greek sigma to denote the selection. The predicate, it appears the subscript. Now what it means, let's first see the syntax. That is, this is the notation or the syntax. This is, here I am defining the predicate, and this is relation on which I am using the select operation. So what it says, let's suppose I want to select all the persons whose name begins with Ram. So here operator, sigma operator, predicate, and then relation. Let's suppose my relation is employee table. So here the name of the relation in this case is my employee table. Now how I will define this predicate? Now this predicate, what I want to select, all the names which are having or starting, which are having only Ram value in it. So that is predicate. In this case, it becomes name is equals to Ram in this case. So here it becomes my predicate. Simple example. So the argument relation is given in parenthesis followed by schema, that is my relation name. So P is a formula. What we have seen, that P is a formula which is consisting of terms. Now let's suppose this is a simple example, but what if I am not aware whether my Ram word, all characters, they are in small caps. Let's suppose it could be this value also. So here I want to check two values. So what I will do, I will use these connecting operators, that is on and operator or and not operator depending upon my situation. In this particular case, I want to have a or operator. So or operator name is equals to this. Sometimes what the students do, they apply this or operator without using the name of the column, that is this is a correct usage. This is a incorrect usage and this is the correct usage. So whenever you are using the AIR, OND or not operator, always give the column names with each and every condition which you want to check. So attribute, then operator, then attribute or a constant, where the operator, it could be my equal to, not equal to, greater than, and so on. For example, I want to select all those employees whose salary is greater than 10,000. Then in that case, how I will write the select operation? Sigma. Then let's suppose my column name is salary. In this case, greater than or equal to 10,000. And then the name of the relation, let's suppose it is again my relation, that is employee. In this example, here I am selecting all those faculties from this table instructor who are teaching the subject physics. So here, or who are working in the department physics. So here department name is equals to physics and then the name of the relation. So here it is the instructor table. So when I run this particular select operation, then all the faculties who are working in physics, they will be shown in the result. Only these entries will be shown in the result. These are few more examples, and such examples we have already seen, that is salary greater than this much amount. Now in this I want to select those instructors of computer science department whose salary is greater. Now two things are there. First, he should be working in computer science. Another, instructor salary should be greater than this. So this is my predicate and this is the name of relation, that is instructor. So here the predicate department name is equals to computer science. Since these two particular things, they need to be ANDed, so I had used the operator AND operator, and then salary greater than 7,500. Simple. Here I am having this relation. Here what I am having, A is equals to B and D is greater than 5. So first one, A is equals to B, this and these three rows, they are satisfying this condition. D is greater than 5. In this case, D is greater than 5. So this one and this one. These three rows, they are satisfying this condition. But what kind of operator we had deployed here? That is the AND operator. So that is why the output is this one and this one. This would be discarded. Why? Because the second condition is not met here. Another important relational algebra operation is the project operation. So in the project, it is a unary operation again. Select is also the unary operation. Returns its argument relation with certain attributes left out. It is shown with the help of symbol pi. All those attributes which we want to appear. So here, instead of predicate, what are having? Name of the attributes. And then my relation R. So this is the notation. Important thing to be noted down, that duplicate rows, they are removed from the result automatically by this statement. If you run the SQL statement, then in that case duplicate rows, they are always shown. But when I am talking about the relational algebra and if you are showing the output, always remove the duplicacy from your output. For example, to eliminate the department name attribute of the instructor, that is, I want to know only the ID, name and salary. So this is how I will pass the project, how I will give the project operation. This is find out the name and salary of all the instructors. So I have given the of all the instructors, no condition. Whenever I want to use a condition, I will give you the sigma. But once I want to see only the selected columns, and then in that case, or a subset of columns, then in that case I will use the pi operator. So find the instructor ID and their respective departments. So this is my relation algebra query, that is pi, and then the name of the columns which I want to show, and this is the name of the relation. Simple example, here I am having 3 columns ABC, but here what I have passed on the attributes, that is A and C. So this is going to be my attribute, but I have already told you that duplicacy are always removed from the final output. So here these 2 rows, they are identical in this intermediary output, so it will be removed, and this is my final output. But we always use projection and select operation in conjunction with each other. They are always used together generally. For example, how we will use them? Let's explore it with the help of an example. I want to display only name and ID. So here projection, but with a condition, that is only those instructors whose department name is physics. So what I will do? First, I will use the sigma operator. This is the predicate in this case. Department name is equals to physics, and then the name of the relation. And I am aware that the output is always a relation. So in this case, whatever I am giving here, that is the output of this is again relation. Let's suppose that is R1. Now, whatever I am getting as an output of this query, it will pass as an input to this outer relation algebra operation, that is pi operation. Now, this name and ID, it will be selected from this resultant output of the innermost relational operation, and then the final output would be shown. Instead of giving the name of a relation as the argument of the projection, we give an expression that evaluates to a relation. That is, I can give this in this form also. R1, then sigma, predicate, and my relation name. And then I will pass this R1. I can pass this relation R1 to my projection operation. I just need to write R1 here. So, if you feel that things are become very complicated for you, then first try to break down your complex question into sub parts, solve them independently, and then do the nesting. Another important operator is the union operation. So just like your set theory, if I am having set A and set B and I create a union, then it will show the output of both the sets. So same thing it will happen here. Instead of having my set, what I am having a relation. So here I require 2 sets or 2 relations here. So it is my binary operation. Duplicate rows, they are removed from the final output. If N, R and S are 2 relations, then this is my notation. For example, find the names of all the bank customers who have either an account or loan or both. So first one, name of all the customers from my table borrower, then with the account from the table depositor, and the final expression becomes union of both the cases. Another example, for example, I am having R and S. When I create a union, then A and B, and these are the rows of this, and these are the rows of this. So this one and this one, they are both common, and we have already seen or discussed that duplicacy should be removed. So this is my final output. Set difference operation, it is denoted by minus sign, allows us to find the tuples that are in one relation but are not present in other. notation is this: in a relation containing those tuples in R but not in S. That is, if this is my relation R, this is my relation S, then R minus S, it will give this output. Set differences must be taken between compatible relations, that is R and S should be compatible. What is the definition of compatibility here? R and S must have the same arity. Attribute domains of R and S must be compatible. For example, to find all the courses which are taught in this semester but not in this semester. So here, the first relation, that is, first I will select all those entries which are being taught in odd, and the year is 2009. So the semester is odd and the year is 2009, relation is section. Then I will select all those entries which are taught in odd but in the year 2010. There are some entries which are common in both and which are unique to this relation, but what is what outcome I want? I want only those subjects which have been taught in odd 2009 but not in odd 2010. So I don't, in this query, I want to discard this part also. So this implies I need to use the minus, that is set difference operator. The same query, this is the output of this is my R and this is my S. So this is the output R and this is the output S, and here these are the subjects which have been taught in 2009 but not in 2010. That is, this is another example. This is R and this is S. So R minus S, if I see, this is the common entry which need to be dropped from my final table. Another important operator is the Cartesian product. Just like your set operation, the Cartesian product is same, but the thing is that instead of set, what we are having the relations. Let's explore this particular operator with the help of example. Let's suppose I am having two relations R and S. So Cartesian product of R and S is all the combinations, that is alpha 1, then all the combinations with the relation S. Then it will take next row, that is beta 2, and its again combination with all the 4 tuples of the relation S. And this is my final output. Your Cartesian product, it is different from the join operation which you have seen in the SQL queries. Here what I am doing, this is very much similar to your set operator which you use in set theory, Cartesian product. Find the names. Another example, find the names of all the customers who have loan at Ridge branch. So we need the information in both the loan and the borrower relation. So what we have done, branch name Ridge, but we have taken the Cartesian product of two relations, that is borrower and loan. So from the result, we can check that we are having a relation that pertains to only the Ridge branch. So here what I am having, associates every tuple of a loan with every other tuple of the borrower. We know that if a customer has a loan in the Ridge branch, then there is some tuple in the borrower that contains his name and borrower loan number, where the borrower dot loan number is equals to the loan dot loan number. So in that case, sigma borrower dot loan number, that is from the borrower relation, this is from my loan relation. And then what I am doing, I am again selecting the branch name is equals to Ridge and the borrower loan. So this is my thing, since we want only customer name. So my customer name, that is the projection, is coming here. So let's, I'm again explaining this query. I want the name of all the customers who are having the loan at Perry Ridge branch. Now, when I'm finding the borrower cross loans, for example, this is my borrower table and this is my loan table. So if you look here, this borrower table, it is mapped to all the 4 instances of this loan table. So there may be the cases which are not the correct ones, which have violated the integrity of my database. So I need to drop those things. So how I had dropped those things? I only need those entries where borrower loan number is equals to the loan number which is present in the loan. So here I am getting this overall data. But here what I am doing, for example, this is my primary key of this and this is the primary key of this. So once I run this borrower.loan number is equals to loan.loan number, so I will get this reference. Here I will get this reference. Rest are dropped out. So this is these 3 rows. Sorry, not this one, this one. These 3 rows, they are the output of this particular relation. But I need only customer name. Let's suppose this is my customer name. So these are the 3 instances in my intermediary result. So I had applied the projection on the attribute customer name. So the final output would be my, let's suppose, B, and the final output, it will contain the result 1 and 2. These are the 2 customers who are having the branch in Perry Ridge. Account and loan, both they are in the Perry Ridge branch. This, the same thing, that is branch name is equals to Perry Ridge, borrower.loan. So this is my loan table, this is my borrower table, and this is the output of this particular query. Once I got this output, on this output I have run this statement, this select operator, and this is the output which I got here. This is the output of this. But since I need only the customer name, so I ran this one on this. So only these 2 names, they are being displayed in the final output. Rename operation. In the rename operation, it is again a unary relation. So here your operator row, then X and E. Now what is the E? It is my expression under the name X. So it allows us to refer to a relation by more than one name. If a relational algebra expression E has arity n, then we could also use here, that is X, and these are my attributes, returns the result of expression E under the name X, and with the attributes rename to A1, A2, AN. This is if I want to rename my attributes. If I don't want to rename my attributes, then I can use this rename operation notation. This is a simple query. Find the largest salary in the university. So find the instructor salaries that are less than some other instructor salary. No, that is not the maximum. We are not saying maximum largest salary in the university, and then using a copy of instructor under a new name of D. We are storing. So here pi, but on which particular your column, that is salary. This is the name of my table, instructor.salary. Here instructor.salary is less than d.salary. Why I have used the d? Because again the same table, I am referring to the same table. So I have given two names. One is instructor and another one is your d. And this is the Cartesian product. Once I am applying this Cartesian product, so at that time I had renamed my instructor table with a new name, that is d. So this will correspond to this and this will correspond to this. Always remember, whenever you are having a nesting of operations, then the first innermost operation it got evaluated, its output, it will become input for the operation, outer operation, and so on. In the step 2, we need to find out the largest salary. So here pi salary, all the instructor salary, maximum we need to find out. So here I had used the minus, that is the difference between the two set, and I will get my desired result. So this is all about my relation algebra. Important relational operations I am having in relational algebra. We have seen select, we have seen project, then the difference operator, Cartesian product, rename, and this particular example, it has shown all the things, that is how to use the project operator, how to use the difference operator, how to use the select operator, and how to use the rename operator. And again, the Cartesian product. This is all for today. Thank you and Jai Hind.